Hello everyone. Today we're going to be looking at a simple logger class that I have created for C++. And I say simple, but it's still quite comprehensive. And I believe that everyone will find it useful, and if you want to build your own, you could use this as a baseline, get some ideas. You could copy it if you want and use it. I think it's useful. So let's have a look. We don't need this comment at the top, okay? But if we look at the actual code, we can skip the includes because that's not relevant to us. And we get to the enumerations, all right? Our first enum is a log level, and as you notice, this is not a enum class. This is just a regular enum. That is beneficial because when you want to, as a little bit of a preview here, if we want to type log and we use an enum class, we will need to use a scope resolution operator, and it would look something like this. But with just regular enum, you don't need to use scope resolution, and we can just type this. It's a lot cleaner to look at. Also, enums implicitly convert to integers, which makes a lot of our calculations a lot easier. And especially this functionality, where if you can see there's a lot of comments going on, all we're doing is we're turning it into a bit mask. If you're familiar with this technique, this shouldn't be new to you, but if you're not, then we won't go too much in depth here. But if you look at trace, it is 1 shifted by 0, and if we look at the bits, there'll be more bits before this, depending on how big your integer is on your system. But it will all be zeros, and it will end in 1. Okay, because that is 1 in binary shifted 0 times. We then go through every log level and shift 1 by an incrementing amount. And if you look at the picture, you'll see that, okay, we shift by 0, we shift by 1 here, by 2, 3, 4, so on and so on, until we get to the final log level, which is right over here. And you'll notice that this means we could probably have 32 different log levels if you have a 32-bit integer. But when you start getting to that amount, and it could be different on various systems, I recommend first casting these to, let's say, a unsigned 32-bit integer so that you can safely shift like this, okay? But that's besides the point. Right now we have 9 log levels and it works just fine. Great. I also have the colors over here which represent the actual log level. This is useful because if we now go into main again and let's say we type in log trace, if we hover over trace, we'll see on the left hand side it will tell us this gray and it will give us the bits. That's very useful. Okay, so I ran the program by accident. Okay, but let's just close this. Okay, that is useful functionality because now when we hover over, we can know the exact color that will be output to the console when we use this log level. All right, all log levels, as the name suggests, literally is just all our log levels, and we bitwise or all of our bits together. As you can see, this forms kind of like a little pyramid over here on this side. If you're familiar with these operations, this should all make sense to you. And similarly, no log levels is just an empty mask of 0 everywhere in every bit position. Okay, and I write a comment here, but that's not necessary. Basically what I say is this means that when we set our enabled log levels, we can do things like say error or critical. It enables us to do things like this, which is very easy to read. Instead of using a bunch of if statements, we just construct masks like this for our enabled log levels. I will now undo this. And this enabled log levels, as the name suggests, it's all the allowed log levels that will be shown to the console. Currently, we're showing all logs. If this was set to info, only info logs will be printed to the console. If it was info and error, only info and error, and you get the point. This means you don't have to go and manually comment out your logs when you don't want a specific log to show. You'll just go to your base log class and implement that over here where you want specific log levels. Okay. Over here, we have another tweakable parameter called the log specific file only. And right now it's set to all, and that means that logs from all files will be shown. But I give a little example here. If you want, let's say, logs from only main.cpp, you'll type main.cpp over here, and only log levels from main.cpp will appear. Similarly, you could do that for any CPP file, and it does not matter the path of that file. You just need to type the file name. We'll get into the functionality of how that's possible later on, but yeah, that's our two parameters. Now let's get into the class itself, okay? For the constructor, when you create a log class instance or an object, you have to pass it a log level and a std source location. And if you're not aware, std source location was added in C++ 20, so this logger is very modern and will only work with C++ 20 and beyond, which is great. You know, we want to stay modern. We don't want to stick with the old underscore file and underscore file name. This is way better and cleaner of a solution. Okay, so, it simply just takes these level and location and assigns it to private members over here. Level location makes sense. And you'll notice we also have an internal buffer which will hold the full input string of your log. And we have an internal mutex lock shared by all the log instances, which ensures that we have thread safety. And don't worry, even if your program's single threaded, this will still work just fine. It's just here in case it's multi-threaded, it will still work, because obviously in a multi-threaded environment, if you're trying to write to the console at the same time and access shared resources, there you're going to have a bit of an issue. So we have a mutex lock over here, and it's static because it's shared by all the log instances. Great. The destructor, what does the destructor do? Okay, first it checks, is the buffer empty? If you recall, the buffer holds our log string. And okay, if it's empty, then we don't need to flush our buffer and output to the console because it's empty, right? There's nothing to log. Great. Else we flush, and we'll get into that later, what that means. But basically that just means we write to the console. Okay. We have our rule of 5 because we declared a constructor part of the rule, or destructor. Part of the rule of 5 in C++ is once you declare a destructor, you will need to most likely declare your copy assignment, copy constructor, and your move and move assignment, etc. Because if you want something to happen when the object is destroyed, likely you want to handle how it's copied and whatnot. You know, we won't get into the detail of that in this video necessarily, but pretty much I delete these specifically because I do not want you to be able to assign a log object to a variable, okay? That is important because if you're able to assign a log object to a variable, the lifetime of that variable is unknown, right? It could persist for the whole function, and it could be saved to a member variable class and persist for the whole class instance. It's unknown to us in our little log file, and we don't like that because in our destructor, we actually print to the console, okay? And that means that if we save a log object to a variable and that doesn't get immediately destroyed when we write that log, it means that it might log at an unexpected time, or it might not log at, oh, it will log eventually, okay? The destructor will eventually be called, but it might log at a different time and other logs might show up first because our whole plan is to log on the destruction of the object, all right? So that's why we don't allow assignment or copying. Great. We only want temporary objects. Here we get to functionality. Here we have a templated input type, and we overload the stream left shift or stream out operator to take in any input type. As you can see over here, we take in any value, and simply we take this value and we stream it out to our buffer. Okay. This means we can append, you know, different strings or numbers or whatever we want because it's templated, right? Whatever you could usually print to the console, it should work here. You could overload this for specific class types, but right now, you know, this is how we have it, okay? And it will keep filling up this buffer, and we return a pointer to this object, as you can see reference, we return this exact object, not a pointer to this object. We return this exact object, a reference to it, because that allows us to chain calls like this, which you would usually do. You'd call cout and you'd write something and then you could chain again. Okay, that's what we're allowing with this functionality. All right. And here we have some helper functions. We have our flush that we saw earlier, and immediately the first thing we do is we lock our mutex guard for multi-threading. And this is very modern, this lock guard. It's newer C++ version, might be 20, might be 17, but pretty much you'll notice there's a lock, but we never unlock it, right? And that's because you don't need to with this. It will automatically unlock once this goes out of scope. Okay, so that's very useful. And in a single thread environment, this will lock and unlock immediately. Doesn't really matter, but for multi-threaded, this will lock and no other loggers will be able to flush while we are busy flushing. Great, okay. Then we go to here and we say if is log level enabled. Okay, I mean, that's a reasonable check, because if we go back, we saw, okay, here's our enabled log levels. We need to check if our allowed log level is enabled. If it's not, we don't output to the console. And then we check if is file allowed. Okay, and again, that's another parameter that we specified up here. Is our file allowed for all? They all allowed for all log levels. They all allowed. Okay, these are two checks that logically make sense. And then we set our reset color. This is the ANSI escape character for the reset color for the console. You get many of them. You can Google them. There are many, and we save that into a string. All right, a C-style string. And here's where we actually output to the console. Okay, immediately you'll notice that we get the color. Okay, this is a helper function down here, which we'll get to, but depending on our log level, we log with a certain color to the console. Okay, and then next line is, you'll see a little closing bracket and level to string. Okay, log level to string. This will output the log level as the words warning, error, trace, etc. Okay, we get the time with current time, another function we'll get to. File, get file, another function. Line, we use our location, which comes from that std source location, to get the exact line where this log was called, the exact function where it was called, and the log itself finally right at the end, which comes from our buffer, which we have been appending to using this stream out operator. And over here we unwind that and pretty much give the entire string to the console and output that. Finally, we reset the color at the end because that is good practice. Okay, we're done using our color and we reset it for the next log to make use of. Right at the end, we reset the buffer. It's not really needed since the object gets deleted, okay, because it's a temporary object, but just in case, why not? It doesn't hurt. Just set the string to empty and clear the buffer again. I think it's fine, okay. Here's a helper function where we get the color. We simply switch on our log level that we're currently using for this log, trace, debug, info, warning, whatever, and we return the associated color. And as you can see over here, here are the colors. Default, if the log level is not recognized, we give it the reset color. You could do some error color over here that tells you that you're not handling a case, but I mean, that's a bit excessive. Okay. Here's another helper to get the actual file, because when you use the this std source location dot file name, it gives you the full path. As you can see, the full path of that file, which can be a bit difficult to read when you really only want the actual file you're in. You don't want to know, okay, desktop here, my projects, yada yada yada, main.cpp. You just want to know you're in main.cpp. Okay, so this is what this function does. We get the full file path. We find the last slash in this full file path, and you'll note that we handle both cases, both Unix and Windows. Okay, which is great for portability. And this will return a size t for the last slash in our full file path. If no slash is found, it means it's already outputting the whole file path. It's like main.cpp. It's just main.cpp. So we can say last slash is 0, and then later on we will take substring from last slash till the end. So this will just output the entire file path. But 99.99% of the time, you're going to have a full file path that has slashes and actual, pathing. So we'll move the file path, the slash up by 1, okay? That's just how it's handled in the indexing for the substring. You don't need to worry about that. But then we copy from that slash, 1 past that slash onwards, because we don't want the slash. And we will be left with our file name, and we will return that as an std string. Okay. Level to string, similarly, like the color, you switch on the actual log level, and we return the string for that log level. Default returns undefined, it's not handled. Okay. This outputs the current time on your system for the timestamp on the log. What we do is, again, we're being modern, we're using std chrono, so we're going to get the time point now, and this is very easy syntax to understand. System clock now, that makes sense. But we use auto because this type's a little bit funny. As you can see, it's a std chrono system clock time point. Yeah, so we don't want that. We want to convert our time point to a time t object, which is what we do over here. We say auto, but you could just say time underscore t. It's not that bad to write. But anyway, time now, okay. We get an output stream for the time. And then we have this funny looking macro over here, right? And this is interesting because when you're on Windows, they will give you a warning in your compiler if you do not use their Windows specific local time underscore s function. All right. To convert your time object into the local time string so that you can, output it to your output string. You'll get an error if you don't use this, but it's non-standard, okay? It's not part of the C++ standard, so, some of you might be a little bit upset, but that's just how it is on Windows, I'm not too sure why it's safer, but I guess it is on Windows, so we check your system version if you're on Windows. Then we will use the Windows specific function, and we put this time into a string that we can output to our output stream time stream, and we use this formatting in hours, minutes, seconds. And just to note that this tm info contains the date as well, so if you want, you could put in the date here. I just thought that's a little bit too much. It's up to you, And if you're not on Windows, you'll use the standard compliant local time function. Okay, great. And eventually we'll return this full stream object, the string of that, so that we can output it to the console. Okay. We have some little helper functions. Is log level enabled? Checks the enabled log levels, bitwise ands them. If it's the same, okay, is enabled. Logically, that makes sense. Is file allowed? We get the file, which we went over that function earlier. And we have this boolean, is it allowed? And we first check if the log levels is set on all, or sorry, not the log levels. If the specific file only is set on all files, we return this true always. But if it's not, we will check the specific file and see if that is part of our allowed file or not. And if it's not, we return false. If it is allowed, we return true. Okay, great. Now, you might notice that if we were to use this and create a log object, it's a little bit annoying because for the constructor, you have to pass the level, which is fine. But you have to say std source location. Now, that I used to do that. That got a little bit annoying to type out, right? So what I did instead was I created this simple macro for hashtag define. We have our log macro, and simply pass it the level, and that macro will expand to the stuff that we do not want to write out, which is level and this std source location current. Very annoying to continuously write that out, so we will use the macro instead. And finally, we need to define our static member of the class, which we do down here. And there's only one instance of that. Great. Let's actually use this now. So again, we're going to use the macro. We're going to type log. We are going to output an error log, and we'll say, we'll output a string. This is an error. And just like that. Okay. Let's run it and see what we get. Okay. And if we can zoom in a little bit here, you will see error. There's the time. File main.cpp, line that, function, int, a little bit annoying, cdec1, but it's main, okay? We know it's main. And we have our log, this is an error. Great. And you can output multiple logs. Let's do a update log, shall we? Update. And let's say this is, this is update 1, to just show you how it will look like with a number. Let's log that out. And here we go. We have our error and we have our update. Yada, yada, yada. This is update 1. I forgot to put a space. Yeah, you know, like we could put a space, but you get the idea, right? This is how our simple logger works. And I presume that you guys might have some improvements. Another one would be maybe allowing the person to log to a specific file. Give that as an option. And also right now, we only set the log specific file to one file. Perhaps you could do an improvement to allow multiple files to be logged to the console. But, you know, right now, let's actually test this, right? So we have error and update. Let's change this all log levels to only log error logs. And if we do that, you will see, okay, we only get the error log without changing any of our logs, guys. We're only editing right over here in our header, which makes it really, really useful. There's our update. And if we use the bitwise OR operator, we should get both now. And there's both. Great. And we'll set that to no log levels. Let's just show you that this works. No log levels. We should get no log levels right now. And there we go. No log levels. Let's set it back to OR. Okay, great. Now, if you guys want the full source code for this, I'll upload it on GitHub or something and give you the link in the video. If you have any questions, drop them down below and I will answer every single question that you ask. And if you have any ideas for future videos, please let me know. If you want to see something else, let me know. If you enjoyed the video and you actually genuinely found it helpful, please like the video, subscribe, because I'm planning on making a lot more C++ related content, specifically for SFML and game development. If you enjoy that type of content, then it's definitely worthwhile to subscribe. All right. Thank you. And until next time, goodbye.